Alright, hi everyone, welcome to my channel, City of Electrons. So we'll consider from the last video. That's where we left off. Okay, so the last video we talked about this guide starting top, how to get this. So we arrived at this from the previous video. So do well to check that out. Now, note that if the supply voltage is constant, then the flux and the rotor EMF equals 1. That is if the supply voltage is constant, then the flux and the rotor current, rotor EMF is 1. And what that means is that this guy here, this is the rotor EMF, it will be 1. And if this is 1, what you have left will just be K and R2. That's what you have left. And then to have this as 1, meaning here will also be 1. Okay, all you have on top here will just be R2. Now, it means this is what you have. I believe that's obvious. Like, look at this, and then look at what we have here. The difference is just that this guy is out. So that's why it's out here. Of course, when one multiplies this, it will remain the same. And that's the reason why we just have this. And that's when the voltage is constant, supply voltage. And that's when the supply voltage is constant. Okay, now also the starting torque, if maximum, it should be is. The starting torque is, the starting torque is maximum when rotor resistance equals rotor reactance. Now, this can be proved by taking the rate of change of torque with respect to change in rotor resistance. For maximum torque, we set derivative to 0. That is, torque is at maximum. So I'm going to show that right now. So when we say something is at maximum, okay, something is at maximum, that is the change. The derivative, which is the change, is 0, meaning there's no change. Okay, this part is just parallel to the x-axis. But in this case, T, which is torque here, let me put that here. T, the torque, and then the resistance. So the change in torque with respect to resistance at maximum, it's 0, there is no change. So what we are going to do, we are going to take the derivative of this expression. We are going to differentiate this with respect to resistance. And then our solution of this differentiation will set it equal to 0, because we are looking for the maximum torque, and at maximum the change equals to what? 0. So let's do that here. Alright, so this is what we have here. Starting torque. Okay, this guy, look at it here. We're taking the derivative now, so we're saying change of this with respect to change in this equals, look at this expression now. So we are going to differentiate this guy. Okay, so what happens here is that we hold what we have under, which is this, and we differentiate what we have on top. Okay, we differentiate what we have on top. It's just following this principle of a quotient rule, u over v. And then that is, we say hold the bottom, then we differentiate the top. Okay, then minus, we hold the top and then we differentiate the bottom, all over square of the bottom. This is what we are going to do. Now, looking at this, what do we have at the bottom? This. So we are going to hold it, which is this v, this guy. So this thing here, hold it here. Okay, I was seeing this expression straightforward. Then this k1 is a constant, so we'll just bring it out. So bring out k1 and we'll differentiate what we have inside. Bring out k1. So what will be left on top? Or we'll remove k1. This will be left. And if you differentiate this with respect to r, you will have 1. Okay, so that's how we have this and this. Minus. Now, this is this minus there. So the next move now is to hold the top, what we have on top, this thing. we are going to hold it up, which is this R2. We are holding it up now. Note that K1 has been removed as a constant. So we hold it up and then we differentiate the bottom. So this is the bottom, we'll differentiate now. So this is the bottom, we differentiate now. So differentiating this, when you differentiate this part, you get what? 2R2, which is this 2R2. Plus, when you differentiate this, of course, there is no R here. We are differentiating with respect to R. So when you differentiate this, you get what? 0. So what we have here is 2R2 plus 0. Of course, the plus 0, you cancel that out, like it doesn't mean at this point. Okay, so this is what you have here, and then all over the bottom squared. What do we have at the bottom? This bottom squared. Okay, so all we've just done is differentiation, and this video is not for differentiation, so I won't go further into that. After all, we are just trying to prove that at maximum torque, reactance equals rotor resistance. Okay, so let's simplify this further. K1 comes this way, and then we'll just open this bracket. 1 multiply everything here, they remain the same. Minus this multiply this, what do you get? 2R2 squared. 2R2 squared, okay? The bottom remains the same. Equals to, these are K here, and then we just expand, saying R2 plus this, we bring it here, right? All over, this is what is happening here. This guy we share like this way, same thing here and same thing here. If we take the LCM of this expression, we are going to come back to this one. So all we did was just to separate this guy. U be the denominator for this. Also U be the denominator for this. That's what we have here. Okay, this way. This way. Clear? Alright. So with that being said, we can proceed further. Now look at this. This is exactly the same as this. However, we have 2 of this. You see that this is squared now. So everything here, it's written twice. So one part of it will now cancel out this part. Okay? So we'll now have 1 all over this, which is this guy here. Hope that's clear. Minus 2R2 squared. Minus 2R2 squared over this. So this is what we have now. Okay? Now, when you set the derivative of equation 1x, which is this or asterisk 1, when you set this thing to 0, you are going to have this. Remember, we are setting it to 0 because at maximum or minimum point, but at maximum point at this at our discussion now, at maximum point, the change, which is this derivative, equals 0. So we'll now say 0 equals to all these things we have here. Okay, and of course when you divide both sides by K1 is knocked off. Okay, so you just have this left, and then what happens next? We bring this guy to the left hand side, so you have this equal to this. Now you can cross multiply, meaning all this guy come this way. Okay, and this guy go this way. So once you do that, like we bring this guy this way, we bring this guy this way, cross multiply. So that's why we have 2R2 squared times this, which is what we have here. Okay, and then 1 multiplied by this, it remains the same. Okay, and then what happens next is this. Look at this. This is exactly the same as this, just that we have 2 of this. That's why I have the squared here. So one part of this will multiply, we cancel out this. Okay, it's just like saying we write this in 2 places. Write this once, write it again. That's what we mean by this squared. So one part of it will not cancel out this part. So what will be left is what? 2R what will be left is 2r2 squared equals r squared plus x squared. Okay, and of course at this point you can bring this guy to this other side, which will now be what? 2r2 squared minus 2r2 equal to x squared. This minus this will leave you with just 1, which is r2 squared equals this. So we can see that it's the same. We can even complete this by saying r2 equals x2. Yeah, because this can just cancel out. Okay, if you want to put it that way. But for this to be equal to this, it also means that this is equal to this. So yeah, that's just the proof of that. That's just the proof of that. But in case you feel like, oh, why all these many calculations, this and that, just bear in mind or have it in mind that at maximum, the starting torque is at maximum when the rotor resistance equals rotor reactance. That's what we have here when we set the derivative to 0, because at maximum derivative is 0, we have this. Okay, so of course you have to pause, watch the video again, check again and again, and then I hope you get it. Of course, questions in the comment section, even contributions and more clarifications in the comment section. Like, share, subscribe, click on notification bell, and I'll see you in the next video. Thanks for watching, and bye for now.